A bubble sort repeatedly compares adjacent values and swaps them if they are in the wrong order. A bubble sort uses a flag, which is a Boolean variable, to track if a swap has been made in the current pass through the list. The sort finishes when a pass is completed with no swaps being made. That would be the flag staying false. Let's look at how a bubble sort works on this set of data to sort it into ascending numerical order. Adjacent pairs are compared and swapped if they are not in the correct order. 8 and 12 have been swapped because 12 is larger than 8. When a swap occurs, the flag is changed to true. This is used at the end of a pass to check if another pass is required or if the list is sorted. The next two values are compared. Be careful not to accidentally skip ahead. For example, checking 7 and 16 instead of 12 and 7. 7 and 12 are swapped over. The flag remains true after the first swap of the pass until the end of that pass. The next two values, 12 and 16, are compared. These are in the correct order, so no swap is required. 16 and 10 are compared and need to be swapped. The final comparison of the first pass is 16 and 11, which requires a swap. At the end of the first pass, it is guaranteed that the largest value will be sorted to the end of the list. The flag is checked at the end of each pass. If it is true, it means at least one swap occurred during that pass, so the list may still be unsorted and another pass is required. If no swaps occurred, and if a flag is false, then the list is sorted. If you are asked to show how a bubble sort works on a given set of data, and that can be numerical or alphabetical in an exam, you don't need to show every individual comparison. Each swap is recommended, or at least showing each pass. At the start of each new pass, the flag is reset to false and the comparisons begin again from the first pair of values. 8 and 7 are compared and need to be swapped. Making this swap changes the flag to true. No swap is necessary for 8 and 12, but 12 and 10 are in the incorrect order and need to be swapped. And 12 and 11 also require swapping. The final comparison of pass 2, 12 and 16 does not require a swap in this example. We can see that this list is now sorted because it's a very small data set of only 6 values. However, because the flag is true, the algorithm must start again for one final pass to ensure it is fully sorted. A bubble sort algorithm only stops when the flag is false at the end of a pass, confirming that no further swaps are required and the list is sorted. The flag is reset to false and each pair is compared in turn. In this pass, no swaps are required. Completing a pass with the flag still at false is the stopping condition of a bubble sort and the list has been sorted. An advantage of a bubble sort is that it is simple to understand and program. However, a bubble sort is usually much slower than both an insertion sort and a merge sort, especially for larger data sets. You do not need to memorize any searching or sorting algorithm code, but you may be shown code and asked to identify which sort or search it is. And remember, there's no one way to write a bubble sort either, but some of the clues you're looking for include a flag to check if values have been swapped, swapping adjacent values, for example array I equals array I plus 1, and an outer while loop with an inner for loop. The outer loop continues until the flag is false, and the inner loop cycles through the list from the start to the end to compare each pair in turn.